Okay, are you ready?
Yeah.
Are you ready? Toad, you ready? Okay. Miguel, do me a favor. Explain to Toad why he's not ready. Oh, thank you, thank you. Okay, appreciate that. Now, you ready? All right. Class?
Yes.
All right, thank you. So, thank you very. Why are you hiding your face like that? No. Yes. Be excited about being here because I am. I'm excited to be here because I'm here to teach you something and I want you to pass. I want you to pass. I want you to pay attention, and I want you to do good. You know, like all things in life. Do everything to the fullest. And so, what page are we in the notebook? 31. So, permutation. It is like what we did previously, just a little bit more complicated. It's like yesterday's notes, but a little bit more complicated. Permutation is the ordered arrangement of items that occur when no item is used more than once. Okay, let's go back to our warm-up that we were talking about. The warm-up started off with 4 letters, right?
Yeah.
Okay, so now, if I cannot repeat and I cannot use it again, so the first choice I have 26, right? So after I use one of the letters, what about the next one? How many choices do I have left? 25. Then after that?
24.
Then?
23.
Is that super easy? That's what that is. So we cannot repeat, and the order of arrangement makes a difference. The order does matter. The order matters. Okay? So if I have 3 people that just ran a race, okay? Yes, we have 3 people running a race. Great. All 3 of them are running. And we get first, second, third. Does order matter? Yeah. Order matters. Because you wanna be the person who gets first, right? Or be like most people that just trip Toad and let him get caught by all the zombies. So yes. Zombie apocalypse, I'm hanging out with Toad because first sign of zombie, I'm tripping that fool. Right there. Okay? He's gonna be a light snack for some zombie. Anyway. So, you need to arrange 7 of your favorite books. You guys know what books are? You guys ever have any in your classrooms where they're like these things made out of like parts of trees? You guys, yeah, I know that's archaic, right? So, favorite books along a small shelf. How many different ways can you arrange the books, assuming that the order of the books makes a difference? Okay, so how many books? Say 7, right? Okay, 7. So I'm going to go 1, 2, 3, 4, 5, 6, 7. Now, the book that I'm going to choose first. What book am I choosing first?
Astrology.
Astrology? Okay. I was hoping you'd actually say like a real book, like like something you're actually reading.
There are plenty of books with that actual name. They're separate sub names.
I was hoping you'd just say like a book that you have.
Okay.
Oh, okay. I was like, I'm currently reading Arcane Ascension. So anyway.
You read books?
Yes, I am that old. I read books. I know, right? Yes, I read stuff. Okay. Anyway, so how many do I have to choose from in this first spot? 7. Now that I chose one of them, how many choices do I have left? 6. And after 6?
5.
Then?
4.
Then?
3.
And?
2.
Lastly?
1.
There we go. And what do I do with those numbers?
Subtract.
Multiply all of them because that's how I figure out how many different combinations I'm going to have. But there's another way of actually doing this. It's 7 factorial with the exclamation point. 7 factorial. That's what that means. So on my handy dandy calculator, let me see, I'll show you guys how to do it here. So, and so 7, and then you do alpha decimal point. So on NumWorks, alpha decimal point, it's going to give you the exclamation because it's right about there. Not right there. Up in her. Up in her. Anyway. All right. Hit okay. My answer is 50/40. Is that easy?
Yeah.
And for those people that don't really pay attention and don't really take notes and still have yet to take out their notebook, I also put it here on the notes because a lot of people can't seem to actually take down the notes when I tell you to, or to even write down the stuff. Now, along with that, you have this one right here, 0 factorial. This is an identity. It gives you 1. 0 factorial is always 1. I cannot prove it to you. I had to prove it when I was in college taking master level math courses and proving what 0 factorial is. I also had to do a proof that y 1 is equal to 1. But why is 1 equal to 1?
Because one doesn't add or subtract, it's just one.
No, it's not. You just say that, but then you're going through like this whole like 2-page proof of why 1 is equal to 1.
Is that actually a thing?
Huh?
Is there actually a thing where you know like a 2-page?
Yes. Yes, we math proofs. Yeah, where we prove why things are, yeah. Don't do it. Okay? Do you ever want to see a math teacher cry? Yes. Okay? You would have seen me in that. Like, seriously, I curled up in the fetal position, cried under my desk. That's how bad that and difficult that class was.
Sounds fun. That's how I feel.
I know, sounds fun, right? Well, was that you yesterday? Yes. Okay. Okay. All right. Now, we're going to do the math problems here, but evaluate without using the calculator. So we're going to evaluate this first one without using the calculator. So I'm going to list out my first one. The top is going to look like 8 times 7 times 6 times 5 times 4 times 3 times 2 and times 1. Right?
Wait, it already has it for us.
I know it does, but I'm trying to explain to you why.
Oh my
It's
God.
almost like I said that already at the beginning. Now, it's divided by 5 factorial, which is 5 times 4 times 3 times 2 times 1. Now, what happens right here, mathematically, is I'm able to cancel out what is common, what is on top and bottom. Starting at the 5s, cancel those out, 4s, 3s, 2s, and 1s. I cancel that out, and the only thing I have left is 8 times 7 times 6. So by doing this without the calculator, I do 8 times 7 is 56. 56 times 6 is 336. I don't know how many. Yes. Okay. Good. I got a head nod. Does that make sense?
Yeah.
Okay. So without a calculator, we can do it like that. But you still kind of might need a calculator, because if you don't know your 8 times 7s, what's 7 times 4? 7 times 4! 7 times 4! What is 7 times 4? Come on! Come on! I know. It's not 27.
No, I actually can't think right now. It's so bad.
All right, so B. Wow. All right. Okay. Anyway, so doing this same one here, doing this same one right here, let's look. It's going to be 26 times 25 times 24 times 23 times 22 times 21 times, oh wait, hold on. So that's 21 factorial over 21 factorial. Why did I write it like that? Because I'm lazy. But besides the fact that I'm lazy, do I want to write this all the way out to 1? No. Do I need to do that? Say no. Because once I get down to, just like on this previous problem, when they're the same on top and bottom, like the 21 factorial will cancel out with the other 21 factorial, right? So I'm left with just what is in the numerator here. So by doing this by hand, it's just 26, 25, 24, 23, 22, right there. And I don't want to do that because I don't know. What's 7 times 4?
It's like 23.
No, it's not 23.
I didn't say 23.
Okay, so on your calculator, I'm going to write, what was it, 26 over 21. Okay, so 26 factorial and put divide 21 factorial. So we can also do this in the calculator. So I get 7,893, 600. There you go. Está muy fácil? Yeah. So this is what I'm going to do. I'm going to stop here. We're going to pick this up tomorrow. So anything you see on the homework that says NPR, skip that. All the rest of the stuff that you have, because I believe it starts in like question 3 where it does NPR, but then you could jump down to like question 6 or 7. Yeah, skip through, do all the regular ones. Okay. If you did not finish 11.1, do that right when? Meow. Right meow. Okay? But a lot of these problems for 11.2, you can do in the calculator. All right, make sure you all like, share, and subscribe. Hit that notification button. Support my channel.